Hello there and welcome to the series of videos going through the content of A-Level Maths. Here we're looking at forces on slopes. We can answer questions from exercise 5b. So far with force diagrams and with F equals ma, we've looked at horizontal forces where we have two different components. We have the horizontal component that affects the direction of movement or the direction of acceleration, and we have the perpendicular, the normal reaction force. That's the force of the ground back up onto the particle to keep it stationary in that axis, and we also have the weight force that is still in that same kind of dimension there. So we've got two dimensions mostly. We've got horizontal dimension and a vertical dimension for our forces. But when we have a slope in our diagram, we have two different types of axes or two different dimensions. We're going to be working out how fast or how slowly it accelerates either up or down the slope. So we need to know the forces that are going to be acting up and down the slope. So instead of going horizontal and vertical, we're going to be going up the slope, down the slope, and at a right angle to the slope that we call the normal reaction. So we're going to call these forces that are going up and down the slope the parallel forces. That's being parallel to the slope. So the parallel forces will be going up and down the slope, and the perpendicular forces will be this normal reaction that's going to be everything but the parallel forces. However, when you do add weight into this diagram on the right hand side, it is going to be acting vertically downwards towards the centre of the earth. So this is a force that's going to need resolving into a normal direction or a perpendicular direction and a parallel direction. So the weight force here, some of it will move the particle down the slope or up the slope, and some of it will affect the normal reaction force there. So this is the two bits of terminology we're now going to use. We're going to divide forces up into parallel forces, that's the red force going either up or down the slope, and perpendicular forces, that's the blue force here that's going at a right angle to the slope. Right then, so when we're dealing with forces on a slope, we're going to be considering forces up and down the slope and at a right angle to the slope, either perpendicular or parallel to the slope. This is because we're working out the acceleration either up or down the slope, so therefore we need to know the forces up and down the slope. Okay, and then gravity always acts in the vertical dimension, so we're going to need to resolve that force. Now, when we have a box here on the slope, angle 30 degrees on the slope here, with a mass of 3 kilograms, to work out the speed at which this box here is going to go down the slope, we need to resolve this 3g weight force here. So what we're going to do then is we're going to be resolving this force by creating a right angled triangle with one line going down the slope, parallel to the slope, and one line that is perpendicular to the slope. So this red force here will be the force that's pulling the object down the slope. So we're going to resolve this force here. Remember, whenever you resolve a force, the force that you're resolving has to go on the hypotenuse of your right angle triangle, because we want the resolved forces to be less than the 3g force here. So what we need to know now is what angle is going to go inside our right angle triangle here. So let's just work it out for a second then. Let's look at the right angle triangle on the left here. We have a 90-degree angle on the bottom right here. That must mean there's a 60-degree angle up here, and therefore there's a 30-degree angle in here. And by the time you've done a few of these types of questions, you'll just be able to recognise that angle there goes in this position here. You don't need to work it out each time. So let's start to now resolve the forces using this right angle triangle here to work out the blue force and the red force. Ultimately, the red force would be the force pulling this particle down the slope. So in this case here, we're going to have 3g cos 30, cos because this is adjacent to the 30-degree angle here, and 3g sine 30 because this length here is opposite the 30-degree force here, the 30-degree angle here. So the force that's going to be acting down the slope then is going to be this 3g sine 30 force. So this is effectively a force that's pulling the particle down the slope because of the weight of the object. Okay, and for future calculations we're going to need to know what this value r is, and that will just balance out the 3g cos 30 because we don't want any movement in this blue axis here. We're just wanting it to move either up or down the slope. We don't want it to be going through the slope at all, so it's going to be the R force balancing out with this 3g cos 30 force. Right, so let's get stuck into a question then. So a box of mass 2 kilograms is resting on a smooth plane inclined at an angle of 20 degrees to the horizontal. It meets resistance of 2 newtons as it travels down the slope, maybe due to friction or something. Calculate the acceleration of the box down the slope, and if the box starts 10 meters up the plane, calculate the velocity of the box at the bottom of the plane. So maybe a bit of suvat to finish off here. So, in this case here, this is our force diagram. I'd always encourage you to draw out the diagram, and a big diagram at that as well. A really neat, clearly labelled diagram will be able to help you and will do half the question for you effectively. So, we've got the 2 kilogram mass acting downwards. We're now going to need to resolve this force to find the force that's pulling the particle down the slope. So we know the 20 degrees pops into the triangle here. So then the resolved forces are going to be 2g cos 20 and 2g sin 20. Cos that's adjacent to the angle and opposite a sine, so it's opposite the angle. So the force that's going to be pulling it down the slope is 2g sin 20. And the force that's pulling it up the slope is a bit of a friction force that's 2 newtons. Now, that shouldn't restrict the particle from travelling down the slope, but it might slow it down a little bit. And the R force there that we're going to use later on. So, resolving the forces down the slope, and the way that we notate that is with a capital R, and then in brackets an arrow pointing down the slope. So substituting the forces into F equals ma, we're going to see that 2g sin 20, that's the force down the slope, take away 2, well, because it's take away 2 because this 2 force here is acting up the slope in the opposite direction to the other force. Equals mass times acceleration, that's equal to 2 times a. And then calculate the answer, divide through by 2, and we get an acceleration of 2.4, so that's 2.4 meters per second squared. Part B then, if the box starts to 10 meters up the plane, calculate the velocity of the box at the bottom of the plane. So a little bit of suvat here, it's got 10 meters of travel, starts from a stationary position, acceleration that we've just worked out is 2.4, and we don't know the time, we don't need to know the time. So, we're working out a formula that links S, U, V and A together. That's V squared equals U squared plus 2AS. We saw all of the suvat formulas in the first year of mechanics. And then substitute the values into the formula. And we're going to see that V comes out to be the square root of 47, which is about 6.6 meters per second. So there we are. That's how we answer these types of questions here. Let's go for part C then. So find the normal reaction between the box and the plane. The normal reaction is just going to be resolving in the perpendicular direction, the forces that are meeting the plane at a right angle. So if we resolve resolving these forces here, we're going to see that the two of them will cancel each other out because we don't want any acceleration in that dimension. So R is equal to 2g cos 20. Rounding this off to two significant figures is 18 newtons. Okay, let's have a go at another one then. So this time we've got a 2 kilogram force and a 4 newton force that's pushing it up the slope. Here we have an angle alpha, and we're told in this question that tan of alpha is equal to 3/4. Work out the acceleration of the particle. So, ensure you label all the forces and split up the parallel and perpendicular components first. So put in that 2g force first, that's the weight force, and then draw a little right-angled triangle to resolve the forces, to resolve this weight force. Now we don't know what alpha is, we're going to leave it for a little while and then we'll work it out later. So this is 2g cos alpha and 2g sin alpha. So you'll often encounter questions where the angle is given in this way, tan alpha equals 3/4. A good starting point is to find the corresponding values to sine alpha and cos alpha. So remember here that tan of anything, tan is opposite over adjacent, so the ratio of the opposite side to the adjacent side is in the ratio 3:4. So just drawing a little triangle at the side of your page, putting alpha in as the angle, we're going to have 3 on the opposite side and 4 on the adjacent side, because tan always measures the ratio between the opposite and the adjacent side. So now we can consider this right angle triangle here and do a little bit of Pythagoras theorem on it. We know that from the famous Pythagorean triple that there needs to be a 5 on this side. And from this triangle here we can work out the value of sine and cos. Sine is just the ratio of the opposite side to the hypotenuse, so that's going to be 3/5. And cos is just the ratio of the adjacent side to the hypotenuse, which will be 4/5. So at no point do we actually have to work out the value of alpha. We've used some right angle triangle trigonometry knowledge to work out that sine alpha is 3/5 and cos alpha is 4/5. So we'll put them to one side and we'll bring them in when we need to use them. So now we're going to resolve parallel to the plane. So indicating this with a capital R and then an arrow pointing down the slope, we're going to have one force acting down the slope. That is the weight force, that's 2g sine alpha. And we're going to have a force going up the slope that's of a force 4 newtons. You can do it quickly on your calculator to see which one's bigger. I'm pretty sure it's going to be the 2g sine alpha one though. So down the hill is where we're going to be travelling. So in our F equals ma equation, on the left hand side we're going to have 2g sine alpha down the slope, take away 4 because 4 is acting up the slope. When you've got forces acting in different directions, one of them should be negative and one of them should be positive. You've got to decide which one you're going to be setting negative and positive. And then on the other side it's equal to mass times acceleration, so equals 2a. And then rearranging the formula and dividing through by 2, we get 3.9 as our value for acceleration. Okay, so there we are. So if we had resolved up the slope instead, we'd have had a negative acceleration, so you could have just reversed the acceleration and taken away the negative there. Right, final question then, and this one is a toughie. Okay, so what we've got here is we've got a plane, we've got a mass, we've got a particle on the slope with mass, and we don't know what the mass of this particle is. We also have a force that's coming in at an angle pushing the particle up the slope, and the force of this, the force here is a 5g force. This causes the particle to accelerate up the slope of 0.5 meters per second squared. So we know the value of a, so when we come to use F equals ma, we know the value of a up the slope. Okay, so let's get started. The first thing I would do in this question then is to label my mass force or my weight force and then resolve that weight force. So I'll have mg cos 30 going in the perpendicular direction and mg sine 30 going down the slope. Now this 5g Newton force here also needs resolving at an angle of 60 degrees. This is not a force that's acting perfectly up or down the slope, it's a force that's coming in at an angle. So we need to resolve this force as well. Remember, when you resolve any force, that force is going to be the hypotenuse on a right angle triangle. And remember, we're going to be looking to resolve the forces of it going up and down the slope and perpendicular to the slope, so this is what your diagram needs to look like. We're going to have 5g sine 60 going into the slope, sine because that is opposite of the 60 degree angle, and this is going to be 5g cos 60 going up the slope because it's adjacent to the 60 degrees there. So we now have a perfect diagram where we can now work out the value of the acceleration going up or down the slope. M is going to be in our answer, but we know that A is 0.5. So resolving the forces up and down the slope, so F equals ma, So highlighting the forces that are going to go up and down the slope are these two forces here. We're going to have 5g cos 60 going up the slope, and we're going to have mg sine 30 going down the slope. So in this case here, on the left-hand side of our f equals ma equation, we're going to have 5g cos 60 going up the slope, and then mg sine 30 taken away from the 5g cos 60 because it's going down the slope. Opposite directions need opposite signs, and we've decided to set upwards as our positive direction because we're told here the particle accelerates up the slope. Now, it's the m components that we don't know. We do know the acceleration. We know that a is equal to 0.5. So what we've got here is a formula with only m that we don't know the value of. We know the value of g, that's 9.8. So that's not effectively an unknown, that is a known value. So now we just need to rearrange the equation to get it to look like something like this. So the first thing we'd probably do then is work out the exact values of cos 60 and sine 30. They're both 0.5, so replace those values with 0.5. Maybe we might want to double everything then because these all seem to be decimal numbers. Great. And now we need to combine this m value into one single m value by some factorization, and then divide by 1 plus g, so it's going to be 5g over 1 plus g equals m. So there we are. That was a difficult question there. We had to resolve two different forces, and we had to work out an unknown in the mass rather than the acceleration. Okay, so your turn to have a go at this question here then. Pause the video and try this question out. Okay, so another tricky question here. These questions aren't easy, but let's draw a diagram and hopefully we can visualize what's going on. We have a plane at an incline of 30 degrees. We have a mass of m, so this is going to be a weight of mg, and then I'm going to draw my resolving forces triangle in, so I'll have here a 30-degree angle up here. This force here is going to be mg cos 30 because it is adjacent to the 30-degree angle here, and this one here is going to be mg sine 30. So let's read on in the question. The normal reaction between the plane and the particle is 5 newtons, so this force here is 5 newtons. Calculate the mass of m, the particle. So what we can do here, instead of going straight to resolving up and down the slope, we can resolve the forces that are meeting the slope at a right angle. So this time I'm going to be looking at the forces that are meeting the particle at a right angle, or meeting the slope at a right angle. I've got this mg cos 30 force acting downwards and the 5 Newton force acting upwards. So these two are not going to be accelerating in that dimension, so the two forces must be cancelling each other out. So in this case here, I'm then going to just do 5 divided by g cos 30, and then I'll grab my calculator and type in 5 divided by 9.8 times cos 30, and I get an answer of 3.3 basically. So m is equal to 3.3 kilograms. Part B then, calculates the acceleration of the particle. Well, the only force that I've got acting up and down the slope is the force of the weight, and that is mg sine 30. We now know the value of m, so it's going to be 3.3 g sine 30. So, substituting this into F equals ma, I'm going to have 3.3 g sine 30 equals the mass of the particle, which is 3.3, times the acceleration, a. So I can cancel out my 3.3's on both sides. I know that sine 30 is 0.5, so my answer here is going to be g over 2 as the value of the acceleration. Probably better to write it as a decimal, seeing as we're in mechanics. 4.9 meters per second squared. Lovely, so there we are. That's how we do that type of question there then. So, first time we're seeing forces on a slope here. Do have lots of practice at exercise 5b. Maybe even have a go at all the questions, because there are going to be loads more things that we're going to be adding on to these types of force diagrams working on a slope. So it's really good to have the basics under your belts. So, have a go at plenty of the questions from exercise 5b, and thanks very much for watching.